In the previous video, we looked at metaclasses, what they are, and what they can be used for. In this video, we'll look at what may be Python's most used, programmable, semantic element, context managers. Context managers are pieces of code that plug into Python's with statement. A with statement contains a block of code, and the context manager is able to run its own code, both before and after that block is executed, with the after code guaranteed to run no matter what happens in the block. The Python standard library makes quite a lot of use of context managers. Open files can be used as context managers, which guarantees that the file will be closed at the end of the block. Lock objects can be used as context managers, in which case they acquire the lock before the block and release it when the block is finished executing. SQLite database connections can be used as context managers, allowing them to automatically commit or roll back their transaction when the block finishes. There are other examples, but we can already see how useful context managers can be. They simplify the code by combining setup and cleanup into one thing, and they improve the code by guaranteeing that the cleanup code actually gets run. So how can we write our own context managers? There are actually two ways. The simplest is to use the context_lib context manager decorator on a generator function. As we see here, when we create a context manager this way, we can write it as one continuous piece of code. We can think of the yield statement as a proxy for the whole code block that the with statement contains. If that block raises an exception, it will look to our context manager code as if the yield statement raised that exception, so we can wrap it in a try statement to deal with any exceptions that might occur. We saw the as clause of the with statement when we used file opening as an example of a context manager. That lets us bind a value returned from the context manager to a variable accessible within the with block. If we yield a value from our context manager code, that value will be the one assigned through as. In this example, we yield a function that prints the word during, so the entire result of our with statement is that it prints before, during, and after in that order. We can also write context managers by adding enter and exit methods to objects. Any object that properly implements those methods can be used as a context manager, which is how objects such as open files and database connections are able to do double duty as context managers as well. Here's an example in which we create a specialized version of a dictionary which could serve as a context manager. Within the scope of the with block, we can read and write data through the object that we returned from enter, but those changes will only be applied to the main dictionary if the block exits without raising an exception. The return value of the enter method is used by the with statement for the value to assign through the as clause. So in this example, the variable trans contains a chain map instance. Chain map objects are dictionaries that can have a parent dictionary. If a looking in the chain map fails, if looking in the chain map fails, it tries looking up the same key in its parent. The exit method needs to accept parameters that specify the exception type, exception value, and trace back if an exception was raised in the with block. If no exception was raised, those parameters will all contain none. If an exception was raised, we need to decide whether and how the context manager will handle them. In our example here, we decide whether to apply the changes to the main dictionary based on whether or not an exception was raised, but otherwise ignore the exception. If we wanted Python to consider the exception to be handled, we could have returned true from the exit method. That would be functionally equivalent to catching the function with a try except statement. There's another variation of the class-based context manager, which supports asynchronous, coroutine-based context management. For the asynchronous protocol, the double bar enter double bar and double bar exit double bar methods are replaced by a enter and a exit coroutine methods, and the context manager is invoked by an async with statement. That small change buys us the ability to have the enter and exit methods invoke other coroutines, wait for data to come in from the network, and otherwise behave nicely in an async.io based program. In this video, we saw how context managers work and learned how to make our own for use in either synchronous or asynchronous code. In the next video, we'll look at one more way of programming the semantics of basic Python operations when we look at descriptors.